What's up, guys? It's Kene once again. Today, I shall be talking about the math module in Python. So, a module is a file that already contains constants and functions that you might find useful in your own program, right? So you don't need to code from scratch. That's what it is. Imagine you want to sum numbers and you have to do that using a loop and writing it by yourself while while you could just call a method in the Python math module, for example. So you see, it makes your coding much easier, right? So guys, let's just get right into it. I'll share my screen and we'll see, beginning with constants in the math module. I have the pi, the tau, e, and the inf. The infinity. The pi, you could think of it as the ratio of the circumference to the diameter, whereas the tau is the ratio between the circumference and the radius. These are constant values, right? They don't vary. And then the e is the base of the natural logarithm of numbers. And that's what you call the Euler number, right? Then the inf, which here, given this math.inf, returns the math.inf there returns the positive infinity. Because if you wanted to access the negative infinity, you simply put a minus sign here. So that's it, guys. And yeah, if I run my program, we'll see these values here. Before you use a module, please guys, you need to import it. As I said, it's somewhere, you know, within Python, and you need to import it into your program using the import keyword. So what I try to do here is check for equality. So I'm trying to see if the positive infinity from the math module here is the same as the floating point representation of the infinity. That's just what I'm trying to do here. And we'll see if it returns true or false. So Control Enter in Jupyter Notebook, and I see the values here, of the constants, and then my check for equality returns a true value. Okay, so guys, let's go straight into the methods available in the math module. The cube roots, CBRT. The CBRT method there, it takes an argument, right? And that argument is used to compute the cube root of the number provided. So if I say 64, what will be the cube root of 64? Voila, 4. And the result or the return value is a floating point number, 4.0 in this case. Okay, so that's how to use the cube root. The ceil. Now, the ceiling, as the full name is, it's just simply going to return a value, an integer value that is greater than the argument provided, and that integer value has to be the least possible value. It must be the least possible integer that is greater than the value provided. Let me just use an example here to show us. If I have 5.2 and I call the ceil method, it's going to give us a number greater than 5, and that number must be the least possible integer. So I should think it is 6 in this case, right? The next integer after 5 is 6. Let's see if that's what it gives us. 6, correct. So it doesn't matter. You could make this 5.7 and it's still going to be 6. No problems. All right. Then the combination, the comb method, it just seeks or returns the number of ways that k items can be picked from n items. So I have n items. In how many ways can I pick k items without repetition, and without ordering. So there's no order to it, and there is also no repetition. Guys, remember maths class and permutations and combinations. So we can do that using the comb. We can do combinations using the comb method of the math module. So I'll provide the items, the number of items. I could say 9 in this case. And in how many ways can I pick 4 items without repeating and when there is no ordering? Okay, so let's see, guys, what that gives us. Voila, in 126 ways. Good. The degrees method, it simply takes a radian value and returns the degree equivalent of that angle, of the value of that angle, right? So if I have 1 radian, for example, in degree, what would it be? Let's see, guys. It's 57.29 degrees. It's as easy as that. So this you find very useful in trigonometry. That's it, guys. All right. Now let's see. The math, I'm not going into details, like going into the math thing per se. It's just to give us an idea of how to use these math modules. And using a module doesn't mean that you do not have to think anymore. Remember that if you are confronted with a problem, you need to think about the problem. Just draw up steps you take to solve the problem. So there must be an algorithm to solving the problem. And then, having got the algorithm or the steps to solving the problem, you can now maybe go online and just get a built-in method to tackle a specific area of that problem, so that at the end of the day, calling different methods, you finally arrive at your solution. So saying that these methods are part of the math module, it doesn't in any way mean that you do not have to draw up your own algorithm. Okay, so the EXP, what does it do here? This here takes the base of the natural logarithm of a number and returns returns its value raised to the power of the given argument. So what I'm saying here is that if I have 1, it's simply going to, for example, take the Euler constant and have it raised to the power of 1. That will be the returned value. Okay, so let's see, guys. We see that it's 2.7, blah, 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 blah. And it can even be 2 raised to the power of 2. Right. Then the EXP2, in this case, you have the 2, you have 2 there, and raised to the power of the given argument. So that value is returned. So it takes 2 and raises it, in exponential notation. You have 2 raised to the power of x, right? So let's say the x is 3. So 2 raised to the power of 3 should give 8 as a floating point number. So 2 times 2 times 2. Okay, guys. Then the farbs, it's simply going to return the positive value of the given argument. So a negative argument, you get the positive value or equivalent of that number. So let's say -6 should be 6. Right. Okay, so guys, let's look at the factorial. Again, imagine the stress you save yourself by using the factorial method, built-in method in Python. If I wanted to get the factorial of, if I wanted to get 9 factorial, that would be like 9 times 8 times 7, decreasing by 1 and multiplying those numbers till I get to 1, right? So, I mean, why don't I call the factorial method? So, 9 factorial, what should that be? You have these numbers. So, believe me, 9 times 8 times 7 times 6 times 5, all the way down to 1 will give you this value. Let's take one that is very simple. Let's just take 3. So 3 times 2, 6, 6 times 1, 6. Let's see if that's the case. 3 factorial, we'll see if it's 6. Voila. So that's it, guys. 3 factorial returns 6. What about floor? Now, the floor is the greatest integer value. The greatest integer value that is less than the argument provided. In other words, if I have 4.7, so I need a number that is less than or equal to this 4. I mean, less than this argument provided, less than 4.7, and it must be an integer value. Say 4, right? 4 happens to be the greatest integer before 4.7, before you get to 4.7. So this will return 4. That's what I'm saying. And even if I made it 14.17, it will be floored to 14. That's it. Okay, guys. Now let's go to the now what's the practical application for this? I would very quickly show us how to use floor to get a random number from, say, 0 to an upper limit. To do that, I'll just import the random module in Python, import random, and then simply do random, use the random variable there, and then call the random method. So it takes a number from 0 up to the upper limit. Okay, so usually it's not usually, it is 1. It is 1. So it takes a number from 0 to just it doesn't get to 1, right? From 0 to a point before 1. That's what the random method will generate. And then I'm going to multiply it now by the upper limit. So it doesn't really get to that limit. So for example, if I multiply by 5, then I'm going to get a number between 0 to 4, but definitely not 5, okay? Then I'm going to floor to actually ensure that I get the desired result. I'm going to call the math.floor method. And we'll see what that gives us. Run. That's just going to be my random number. And I'll just output R. So you see, that gives us 2. If I run again, 4. If I run again, 3. Just like that. 0, 4. So that's how you can use the floor method to generate a random number. What about the F mode? In this instance, guys, simply the remainder, so to say. What will be the remainder after division operation? That remainder will be returned by the F mode method. So guys, let's see if I have 19 or 20. Let me say 20, and that is divided by 3. What will be the remainder? Okay, so your guess is as good as mine. 2, right? You say 2. Let's see if that's the case. So you are correct if you went for 2, 2.0. That will be the modulus resulting from dividing 20 by 3. 2 is the remainder. Now the fsum method simply takes an iterable, adds up the members, all the members of the iterable, and returns the value. So I could say a list. I could have a list of numbers 1, 2, 3, 4, 5, 6, 7. And what will be the sum of all the numbers in the list? I would run and I see that the sum of all the numbers is 28, right? Okay, so that's just as simple as that. Imagine having to do this in a loop, and you keep summing and adding the next item in the loop to the previous sum. That's going to take, your coding time, won't it? So it's just called the fsum method. Right. Now the GCD, which here I could call the greatest common divisor, or in certain parts of the world, like Nigeria, it's called the HCF, highest common factor. So what's the greatest number, right, that can be used to divide a series of numbers, leaving no remainders, without remainders, right? Okay, so I am going to provide the numbers 18, 24, and maybe 30. Okay, so that's it, guys. So what's the greatest? 2 is a factor, no doubt, but it's not the greatest factor, right? So again, if I take 3, I'll check. Okay, fine. 3 can go in 18 without remainders, can go in 24, can go in 30. But that's also not the greatest factor. And that comes to 6, right? So let's see if 6 is actually the answer. So 6. All right. So guys, we see it's good. I'm drawing attention to something. Just take note of the data type of the return value. It's an integer in this case. Okay. All right. Now, what about the hypotenuse? The hypoth, please, when calling this function, the identifier is hypoth, not hypotenuse, even though it refers to the hypotenuse. That is the square root of the sum of the squares of the arguments, right? So the arguments could be the base and the perpendicular side of a right angle triangle. So if I have the base here, 5, and the perpendicular side as 12. So I need to square the arguments. Square of 5, 25, square of 12, 144. And I sum them up to get 169. And I'll look for the square root. The square root of 169 is 13. So you see that the answer will be 13. So that's it, guys. That's how you use the hypoth method. Okay, now for the other function there, the is not a number, is none. It simply checks if the provided argument is not a number. If it is not a number, then it is true. But if it is a number, if it is a number, then it returns false. After all, it's a number. So if I have 5, is n is going to return false. 5 is a number. Yes. So for me to get true, the given value should not be a number. For instance, I can say math.nan. So this is like a constant here, right? And it's not a number. So this is going to return true. If I check if math.not a number is not a number, it will return true because it's not a number, right? So let's see, guys. We see that it is true. Not a number is not a number. I don't know. So, guys, that's just what you use the is nan for. Right. Then the I square root, integer square root. There's a slight difference between the square root method and the integer square root method, the I square root here. But the I square root, it floors, it rounds down the square root of the argument provided, so that the return value is always an integer. That's what I'm saying. So you know that 17 is not a perfect square, so there will be it's supposed to have to be a floating point value, but it's just going to round it down to a number that's that to an integer, just round it down to an integer, right? So what do you think? 17. What's the nearest perfect square to 17, but not greater than 17? 16, that should be. So what's the square root of 16? 4. We'll see if that's the answer. We'll see that it is 4. So please, the I here simply stands for integer square root. It floors or rounds down the square root of the arguments provided. Okay, now I continue. Talking about the LCM, it's like the opposite of HCF, right? Of GCD as the name or identifier for that method, GCD. The LCM, as the name implies, is the lowest common multiple. So what's the lowest number, that is a multiple of the set or series of numbers provided? Let's just look at an example here. So I have 5, I have 10, and I have 20. So what can I say is the multiple? The lowest. In other words, what number, right, can 5 go into without remainders? Can 10 go into without remainders? And can 20 go into without remainders? The smallest number. I see that it's 20 because 5 can go in 24, no remainders. 10 go in 22, no remainders. 20 can go in 20 once, just one with no remainder. So the LCM there is 20, right? Let's see if that's the case. So we see that the answer is 20. That's how you use the LCM. I mean, just as easy as that. You don't need to start breaking down the numbers by yourself, No. Just use the LCM method of the maths module. Now the log 2. So I have a number with log 2, right? What will be the output? For example, I have 8, right? Log 2 base 8, for example. What would be the return value? 3, right? So it's just like saying, oh, okay, how many times do I have to multiply 2 by itself? Like, how many 2s will I get multiplying all of them to get 8? There will be 3 2s, right? So that's how you use this log 2 here. The base of 2 raised to the power of what? 3. So it's that the exponent that raised to the power that this log 2 returns, right? And in this case, I see that it is 3. Let's see, guys. So that's it. And you could also have it as maybe 32. 32 should give us 5, right? So 2 times 2 times 2 times 2 times 2 in 5 places. That is the return value, 5. Okay, now let's take a look at I'm just trying to simplify things, guys, without going into very complex mathematical explanations. Okay, now what about the mode F? We looked at the F mode. They can be quite confusing. The F mode gives us the modulus value, but the mode F takes one argument and gives us a tuple of the integer part and the fractional part of that floating point number. Let's have a look at it, guys. So I have 34.67, right? So calling the mod F, I would have the 34 as the integer part and 0.67, blah, blah, blah. So that's like the fractional part. And the two parts will be contained in a tuple. Let's see, guys. So that's it. So here the integer part here as a floating point number. So you see 34, that's the integer part. And then the fractional part here as 0.67. So that's the mode F method. Okay, now the perm, which is like permutation, the perm method, it's like the comb method. The only difference here is that it is ordered. It is ordered. That's just the difference. For the comb, the items are not ordered, right? So let's see, still having two arguments there, for example, I can say 9 and 4. So you see that I have 3,204 ways. There are 3,204 ways of taking 4 items without repetition out of 9, right? And these items are ordered. Okay, right. So guys, let's go to the POW method. As you can see, guys, you have some idea of what this means. Power, raised to the power. So for exponential computations, right? So if I have, say, 6 raised to the power of 3, what would that be? Okay, let's see. 216. Right, so that's it, guys. That's how you use the power method. It simply means power, raised to the power. So x raised to the power of y. That's what it is. Okay, then the math.prod. Again, as the name suggests, it's the product of all the members of an iterable, a list, for example. It could even be a tuple, right? So let me just change this now to say 2 and 3 and 4. Now I need a method that will just return the product of these 3 numbers in the list. And I need it to begin right from the very first number. So this is the second part. This is the second, this third argument here. Now you might wonder, what does this entail? Like if you look at the documentation, using this asterisk simply implies that the following argument must be a named argument. That's what it is. It must be. I mean, I can't just say, for example, y here now. There will be an error. This mandates that the following argument be a named argument. That's what it actually means. Okay, so guys, I just need the default one. Just start from the very beginning. So it's not required. It's not a required argument. Okay, so let's see, guys. Product 24, 2 multiplied by 3, 6 multiplied by 4, 24. So very simple, just very simple. This will come in handy. I mean, if I need to get the product of 10 numbers, of 20 numbers, just put all of them, in a collection, right? And simply call the prod method. Okay, give me a moment, guys. I need to quickly do something. All right, I had to check if there was someone at my door. Okay, so now let's move to the radians method. It's basically the opposite of the degrees method. In this case, you provide the value of an angle in degrees, and the method returns the radian equivalent. So let's say, for example, 45 degrees, what will be the radian value for that? And let's see, that will be 0.78, blah, 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 blah. So guys, you know that the radian, some like just saying, okay, 180 by pi, right? Just by pi, something like that. Okay, so I'm really, 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 really looking at time. So I need to make this faster. The math.remainder method. what does this return? It returns the remainder following a division operation. It's as simple as that. So I take 20 and divide that by 6. What will be the remainder? It simply returns the remainder as a floating point number, remainder 2. 20 divided by 6, that is 3, remainder 2. Okay, now the square root. You remember we looked at I looked at the I square root, the integer square root, and I said that it's the flawed or the rounded down value of the square root, which ought to have been the answer, right? But using the I square root rounds it down. The square root method gives you the floating point representation, the floating point value of the square root of that number. It doesn't give you the integer equivalent, no. So if I provide 17 as the argument and I run, I'll get a floating point value. But if I were to make this I square root, this method I square root, it will give me 4. It just rounds it down. So do we see the difference, guys? So that's the difference, right? I need to make this just the square root so that I get a floating point value. And lastly, the trunk method. As the name suggests, it's when we use the modulus, right? When we use the mod f, we got the integer part of that operation and the fractional part. Now the trunk method returns only the integer part of that of the argument. But in this case, there are two arguments, the number and the divisor. Okay, so the quotient and the divisor. So if I have, for example, 40, let me say 44, and I need to divide that by 9. 44 divided by 9. It's simply going to truncate it. It's not going to concern itself with the remainder, right? So 44 divided by 9 if I'm using the trunk method, it will just simply be 4, 36. Remainder 8, but that's not the interest of this trunk method. It's just going to take 4. Let's see, guys. Oh, sorry. I was mistaking this is actually the mode F. This has just one argument, guys. And got things mixed up. It doesn't take two arguments, just one argument, which is the floating point number. Unlike the mode F method that gives you the fractional part of the number and the integer part of the number, this just gives you the integer part of the number. Okay, I'm in a hurry, so I need to just do this, and that returns just 56. That's the trunk method. Okay, so guys, I hope that's clear. These are some uses of Python math module, right? You have these methods and these constants that you can use in your application or your program. Right. So guys, thank you for listening. I hope you learned something. I'll see you in my next video. Yeah, in my next video, I'll be taking a look at date and time. Okay. All right. So have a great day, guys. I'll see you in the next video. Bye.